In the previous video, we looked at alpha decay and beta decay, and here we're going to look at the third type of radioactive decay called gamma decay. Now you'll notice from the illustration here that the parent isotope doesn't turn into a new element. It's helium-3, and it's still helium-3 on the product side. The difference is that the helium-3 is a little bit less excited, or at a lower energy than it was before. And it's at a lower energy because it has released a photon, which is a ray of light, a gamma ray. And actually, looking at this illustration here, better to say this is a gamma ray. Even though a photon can be defined as a particle of light, we're just going to keep things simple here and say it's a gamma ray. So notice the difference between this one, that what's being emitted does not have mass, it is light. Whereas alpha decay and beta decay emit a particle that has mass. So let's look at an example here. If we've got barium-137, barium is atomic number 56, and we want to show that it has a high energy nucleus, unstable nucleus, and we're going to do that by putting a little star next to it. And if it's decaying by gamma decay, it's not turning into a new element, it's still barium-137. But a gamma particle has been released. Gamma ray. Gamma ray. And the symbol for gamma ray, well, it looks kind of like a fancy Y. That's gamma. So in class, we're going to look at in more detail at these different types of radioactive decay. You should be able to predict the type of radioactive decay if you see something like this star here, for example, that will tell you it's going to be gamma decay, and you should know what to write on the product side. The final thing we want to talk about here is the difference between these three types of decay with regards to their strength. So alpha decay can be stopped even by a sheet of paper. And it kind of makes sense if you think of it, because an alpha particle is large, 2 protons and 2 neutrons. A beta particle is an electron, so it's a little bit smaller, and it can be stopped by a layer of clothing or a few millimeters of a substance such as aluminum. Gamma rays, however, and these are the most dangerous ones, and that's because they can penetrate organic tissue. Okay, similar to X-rays. X-rays can penetrate your tissues, but the X-rays can't penetrate your bone, which is why they're used for X-rays. Gamma rays are even higher energy. To stop them, you would need a few inches of lead, so that would be a vest much thicker than the one that you wear when you go to the dentist for an X-ray, or several feet of concrete.